Hi all, our today's topic is flow in Kotlin. So let's start with the overview. Flows are built on top of coroutines and emit multiple values sequentially compared to suspend function that returns a single value. Similar to iterator, it produces a sequence of values, but it uses a suspend function to do it asynchronously. It generates next value through network request without blocking the main thread. It is similar to Stream API in Java. It emits value of the same type. Like suppose if flow is of integer type, it will emit the values only of the integers. To understand it better, you can imagine there is a lake where a guy travel a long distance to fetch water. What if there is no water one day? To avoid this, there can be a pipe connected to the lake producer, and water flows through the pipe, and you can stop or alter the flow in between using pipes or checkpoints, intermediaries. Finally, it reaches people, consumer, through tap. So there are three entities involved in flow: producer, intermediaries, and consumer. Producer produces data asynchronously using coroutines, which is added or emitted to the stream. Intermediaries doesn't consume the stream but can modify each value in the stream or the stream itself. Consumer consumes the value from the stream. Let's understand it with MVVM example. Repository acts as a producer for a UI related data, and UI consumer displays the data. UI acts as a producer for input events, which is consumed by the layers in hierarchy. View model acts as intermediaries that handle data or events according to the requirements of different layers. We'll move to the next slide. So you can better understand entities of flows through the diagram. You can see producer is emitting data to the flow. Intermediary is completely optional, and it may or may not modify the data or flow without consuming it. Consumer just consumes the data from the flow. Now we'll look at creating a flow. Flow Builder API is used to create a new flow, and emit function is used to emit data manually into the stream of data. Flow Builder uses asynchronous APIs as it executes within a coroutine, but with some restrictions. Like producer suspends until the suspend function returns. Like when network request completes, then result is emitted in the stream. A second restriction is like producer cannot emit values from different coroutine contexts. Like a producer is executing on UI.main thread, then emit will also execute on UI.main thread. So this is a flow builder example. Here latest news, that is data source of producer, fetches latest news automatically at a fixed interval. Data source returns a flow to emit multiple consecutive values. A suspend function just return a single value. Okay. Next we'll look at how we can modify the stream. So we can modify the stream using intermediate operators. Uh, these are applied one after the other, forming a chain of operations executed only when values are consumed. Applying this operators doesn't mean triggering flow collection or starting flow. In the example, you can see intermediate operator map is used to filter favorite topics, and on is used to cache news. Next, we will look at how we can collect from the flow. So flows are cold and lazy and are executed every time a terminal operator like collect is called on it. Multiple flow collectors can cause producer to emit multiple data at different interval. To avoid this, we can use share in operator to share data at same time to multiple consumers. A collect is a suspend function which takes lambda as a parameter and that is called on every new value. Coroutine that call collect may suspend until the flow is closed. Flow collection stops for few reasons. A coroutine that collects is cancelled, which also cancels the producer. When all data are emitted, flow is closed and coroutine that called collect resumes execution. So, so this is now we look at flow collect example. In the example, you can see collecting the flow triggers the producer, which refreshes the news and emit the result at regular interval. In the previous example, we saw producer remain active using while true loop. So flow is closed when view model is cleared and view model scope is cancelled. Now we see how we can catch unexpected exceptions in the flow. A producer can be implemented using third-party library and throw unexpected exceptions, which can be caught using catch intermediate operator. Catch can also emit items to flow. In first example, collect lambda isn't called as exception occurs before item is received. In second example, collect lambda is called as cache news is emitted by the exception. Now I looked at coroutine context. So producer executes on the coroutine context of the coroutine that collects it. Flow cannot emit values from different coroutine context. Due to this constraint, repository layer performs flow operations on dispatchers.main used by view model scope, which is not desirable. Flow on is the intermediate operator used to change the coroutine context of a flow. Flow on changes the coroutine context of the upstream, that is producer, and any intermediate operator before flow on. Downstream flow, that is consumer, and any intermediate operator is not affected and executes on the coroutine context used to collect the flow. In case of multiple flow on, each one changes the upstream from its current location. So this is the example of coroutine context. In the example, upstream, that is map and on each intermediate operators use default dispatcher as the coroutine context. The downstream, that is consumer and catch operator use dispatcher.main used by view model scope as the coroutine context. Next topic is flow in Jetpack libraries. So flow is popular among many Android third-party libraries and is integrated in many Jetpack libraries. Flow is great for live updates and endless stream of data. Flow can be used with room for database change notification. In the example, every time there is a change in an example table, a new list is emitted with new items. Our next topic is convert call-based APIs to flows. So callback flow is a flow builder that allows to convert call-based APIs to flows. A Firebase Firestore Android APIs use callbacks. From version 24.3.0, Firestore KTX includes snapshot extensions that return a flow by default, and we don't need to perform any conversion. Yeah, that's it, and these are the references. So if you like the video, please like and subscribe. Thank you.